and displaying a thing in azimuth, right? You do know that.
No, they don't.
No, I
They
do.
don't know things.
They don't know any of that, dude. They just say,
Azimuth is a representation in of it. The thing in azimuth doesn't mean it's a global projection.
You know what else drives me crazy, dude?
point.
When people call it the AE map, that drives me nuts. Because there is no AE map, there is an azimuth equidistant projection, commonly referred to as the Gleason's map in various forms.
AEP is azimuth equidistant projection, but you know, displaying the weather patterns in azimuth isn't there's nothing equidistant about it. It's not a AEP. It's just showing the weather patterns in 2 dimensions, 360 degrees with a height ceiling. That's azimuth. Most of these people don't know azimuth is a coordinate system.
You know what else drives me nuts?
That's Eric Dubé, right?
And then when they try to do a south polar projection azimuth equidistant projection, I'm like, that is garbage nonsense. Why do you even have that? That's absurd.
Yeah, for people that repeat, we don't understand a lot. They really confuse a lot of things. Just like the ideal that length contraction would only be observable. So first he covers in relativity the fact that all things are moving and all things towards the speed of light, 1/10 of it exactly, would experience length contraction. Then he goes into how one would observe it and whether or not it would be observed if you were on the thing contracting. But he never says nothing's contracting. He actually starts it with everything's contracting because it's all at motion.
Yes.
I mean, our solar system moves at the speed of light. Why the hell wouldn't it contract if it's a relativity?
Because
it ain't moving that fast.
It's something else. Whatever the speed
Listen,
of light is,
I didn't say. Don't explain to me that I can't observe it because I didn't say would I observe it to contract. I said anything moving at 1/10 the speed of light would be. Anything moving towards the speed of light would contract. This is relativity.
You're about to experience how
With
frustrating it
respect to
is to
what?
try to make this point to these people, dude. They literally are going to respond with the observe it thing every time, no matter what.
Yeah, I'm not talking about an observation. So observational attributes don't apply here.
That's all they can say, though.
I'm not even trying to observe it. No,
that is the fundamental. That is the fundamental definition of an observer. That's the fundamental definition of what contraction is. It's a contraction as viewed from a non-moving reference frame.
It's not an apparent effect. It's an actual effect.
The hell is a contraction a non-moving reference frame?
Non-moving
listen,
it isn't
only only an observer.
The funny thing is, Witsit,
only an observer can have a non-moving reference frame because everything in reality is in motion.
Yeah, according to your model.
So let's say that what you're talking about is only about observation, but what I'm talking about is would things moving, all things are moving, under relativity, experience contraction of length?
No.
And the answer is yes.
No.
He said
no.
Yes.
They don't experience.
He starts special relativity with this. What the fuck are you talking about?
Mike,
dude,
you're smarter than this.
You can
Why
read Einstein word for word explaining it, and they'll still say no.
Because you're not reading as usual. You don't.
I did twice. Listen, they get stuck on the second part where he covers all things moving, all things are moving, and length contraction will be experienced. But then he goes into but only observed under these circumstances.
Exactly.
You only have contraction.
Can't comprehend him.
Relative. Why do you think we call it relativity? It's relative to something else.
You can
relative
only understand
motion.
things put in
co-moving reference frame and a reference frame that is not moving.
Yeah.
Relative
yes.
to moving.
Listen, Danny.
Mike, can I
listen?
I listen to you say about 5 sentences. Why can't you let me say one sentence?
Well, you're just going to repeat.
Are you that scared? Are you that scared to hear the truth?
This
no,
man,
I'm not.
I'm not.
Listen, dude, don't interrupt me again because I'm not going to beg you. I don't want to. Listen, who's going to sit here and listen to what you guys repeated all night for weeks on end? You can literally read his papers. First, he describes all things in motion, the universe in motion, and why it would contract length.
Okay, does it contract differently?
Then he covers.
Okay, can I finish it? Can I finish a sentence?
When it will be observed.
Why don't you tell me when I can talk, okay? I have a sentence to say. One sentence.
Well, it's really easy when you use etiquette. All you got to do is wait till the person is done.
You don't
with
stop,
their premise.
Mike. You don't stop. Seriously, come on.
Listen, I do stop. The point is, I don't stop quick enough for you to satisfy you. But then
Blind
again,
hypocrisy.
I'm not here to satisfy you or he. That's not what I
I'm gonna
came
say
here
something.
for.
You kind of faked me out there. I'm going to say something. Okay, so just let me speak for a second. All these velocities relative to relativity, and the terms of relativity, and the definitions of relativity, are relative to something else. That means the contraction from the sun looking at us versus another star looking at us be different. Yet inside this reference frame that's moving, they're not going to see anything. And you can't use a cop out and use the very thing that you're challenging to describe why you wouldn't see it in the test itself, which is just silly. Oh yeah, we don't see the effects of ether going through it or any
What
contraction
is
because
different? You
of
said it would
relativity.
be different.
See, you can't help
What
yourself.
would be different?
Listen, it's not a cop out when Einstein himself said co-moving people in a reference frame or co-moving objects one experiences because they're moving relative to each other consistently.
Yes, there we go. That's a good
So
answer.
you wouldn't observe it, and the things in it wouldn't observe it. The entire thing would contract. He says this. All of it would contract at
With
once.
respect to
With
another.
respect to each
Okay,
other. So
then you.
listen. Hold on. Let's apply that to
Dude, you
Earth.
need to learn.
Stop.
Oh my
Let's
God.
apply this to Earth, the contraption for Michelson Morley, and all the people observing it. They're trying to see a contraction that they're all experiencing at the same time. Everything in it is experiencing that, even the
How
contraption.
much? How much contraction?
It's
How much
How much?
contraction, Mike?
Listen, how
I
much
have the answer.
doesn't?
I have the answer, but how much is?
How
Would you tell
much
me?
does it matter? Because everything.
No,
The
no, not a value. A lot, a
Don't
little. It doesn't matter.
interrupt me.
Will it?
Stop.
Will it be?
Everything
Oh,
within this co-moving reference frame will all experience the exact same contraction. That's the only thing that matters. That they're all equally experiencing it. So whatever he said it, whatever you design to try and measure it, that's going to contract too. So there's no way you can measure it. So if somebody says with saying that, it's likely that this wouldn't measure that because it's contracting too. That's not a cop out. That's just applying the logic of relative motion.
They genuinely don't understand about a mod, right? It's like they just say scripts. Okay, so they'll say relative to what? It's like, okay, whatever. How much would
Dude,
it change? Well, it depends on its velocity according to Lorenz's equation. The point is that it's all moving, which means it's all
me and
contracting.
Indio covered this a long time ago, and there's a lot of arguments that me and Indio gave up on because we just got the Brenda. No, you're
Dude, they
wrong.
can't. Dude, it's
So why
crazy. I've never
waste
experienced something as bad as
an
this one.
education? It's it's okay. So I won't be able to observe it, but that's not the topic.
I know.
And
Did you hear how many times they
it's
say it? He's gonna say it back to you
it's
right now when we take him off mute. And you saw how many times
it's
he kept on
literally
saying,
covered.
dude,
Oh, who
FTF, he
muted
kept
him?
saying
No,
appear.
I'm
It'll
cool
appear
with
like it contracts. It'll appear. I'm like, no,
I'm
not
gonna.
appearance.
appear.
Doesn't
I have something
matter.
a little different. Can I say something a little different than that? What you think I'm going to say? I'll say this, Mike. You mentioned it. We all there's a contractions happening based on our velocity, based on the reference speed difference between you and the sun, for example. So that says we have a contraction. So I said, how much? I didn't mean it. I needed an answer. I just wanted to know, how do you base that value on? It's based on the
Relative to
difference
velocity.
between your velocity. Hold on, your velocity and the velocity of the sun. But what if we had another star? What if we have another star a light year away, and we're going way faster? So does that mean we're contracting more? No, we would have the same contraction
In
based
a
on
relative
wherever we
universe,
compare it. So
it
we can't. Mike, the point is we can't see the contraction because it doesn't happen in our reference
Oh
it,
my
frame.
God,
It
he's just
doesn't
dumb. He's
happen.
just dumb, dude.
listen.
No,
It's
you're
not
just
that it
dumb.
doesn't
It's
happen.
silly. What are you
Listen.
referencing it to, Mike? Mike, if we're moving through the universe at some
Well,
breakneck
if
speed,
you
would
let
that
me
make us?
speak,
Oh,
if you let me speak, I'll answer.
Are
Yeah.
you insane zealot?
Dude, that was
When
wrong.
all things are listen, when all things relative to all things are moving at the same rate of speed, they'll all experience the same contraction. You'll never under those cases observe it only slightly or measure it not at all. So to say you could say that it's not happening, but the truth is it is happening, but we're all experiencing the exact same time. And so is any equipment that we would use to try to measure it. So our optics, so is the light, so is everything. So we wouldn't experience it, and this is what it covers that. But it also says
okay, fine.
it
Okay,
would still
I
happen.
okay,
It's a
I get the
must.
point. I get the point that you think we can't See it, and Witsit's made this point very clear, that because everything is contracting, the space around you, the measuring devices are all contracting, you can't measure it. So I said to you, now let me finish this like 3-sentence analysis here. It's due because it's all contracting around you. You can't notice it. But it's because if you're on the sun, though, you would measure it, and that's basically according to relativity.
Observe
and we would
it.
see a certain. Hold on, just let me finish, please. You would see a contraction. You would be able to measure it if you were outside of that reference frame. You were in a non-comoving reference frame. But however, think about this concept. What if you're actually going through space and a reference to another
Yeah,
star,
that's
you're going
the
even
most
faster?
common
Hold
way.
on. You can't let me get to the punchline. If you're looking at that relative to another reference frame, which is twice as fast, we could see a lot more contraction on that same exact reference frame that you're talking about not noticing or measuring anything. We're seeing a lot more. So
Yeah,
which is
well,
how no stop. You got to think about it for a second. You can't have both. You can't measure a contraction from a certain star and then go for another position which doesn't have the same velocity change
well,
relative velocity.
listen,
Hold
when
on,
we
you're not
reference
thinking about
that,
you're thinking
All
about
right,
what
let
you
him
want to say
respond,
rather than
Zanick. You think
listening.
you're teaching us, and he's about to
No,
I
spit.
you're
know.
not. I am teaching you.
Listen,
All right, go ahead.
I actually learned about this in college, but when we refer to this, we think of something that's not moving in relative motion with everything else that's relative, like a spaceship going into warp speed. That's why on Star Wars and Star Trek, you see where the Enterprise goes into warp speed. They know what relativity is. They did a lot of research, and they make it look like a stretched out beam of light as the spaceship goes faster than anything else in the universe.
Let me help them out here, okay? So, because they're really stuck here, where they're like, no, if you're saying it's like this actual certain amount of contraction, that doesn't make sense because from the sun, then the Earth would contract a certain amount, and then from a star much further away, it contract greater amount or whatever, right? If you're going faster relative to each thing, it's a different amount of contraction. So, how could it be both? And they don't understand. They're actually voicing their confusion based on how convoluted and stupid their own religion is. But here's the answer.
Thank you.
They claim that space-time, everything in the universe is relative, so space and time bends and warps relative to the relationship between two reference frames, and it's simultaneously doing that
Exactly.
with all reference frame overlaid on top of each other. And that is your belief system, and the reason that you're confused is because your belief system's stupid. That doesn't mean that we don't understand it, though, and if you would really soak in what I just said, maybe then you'll just take a breather and try to understand it.
Yeah, so it's like a wave that a surfer's going to ride from, say, Austin is on one side of the universe and I'm on the other, and we're going to ride a wave all the way across it. It's going to warp,
It's such a
dilate, and
simple
contract.
critique.
No, but that's not true, though. We know that
They
space
pretend
time
like
does
they're
not warp
so
due to
well versed in
velocities.
physics, and I'm not that
You're
well
not
versed in
versed.
physics, but they don't ever mention the fact the necessary prerequisite for physics is math and ontology. And they love to talk about the physics, they love to talk about the math. You barely ever hear them talk about the ontology because in their convoluted misunderstanding and a bigoted vitriol against quote unquote philosophy, even though physics is literally just natural philosophy as it was known for centuries, it requires physics, the area of knowledge called physics, requires ontology. And so when Einstein fixes his mouth and his hand to write down his doctrine of his general relativity and special relativity, he supposes a theory that is ontologically absurd. And every
Okay.
time these very simple critiques are made against these absurd ontological doctrines that are the
You
bones
mean
of
to
his
say
doctrine, they just whistle right past it.
it goes against the nature of being? It's metaphysical.
Correct.
Dude, what's funny is, though, let me
Well,
try to teach
I know what you
Well, I
meant.
think it was my turn, actually, but go ahead,
I
Witsit.
No,
wanted
yeah, it's not
people
your turn
that were
because I
listening
need to
to know
teach you
what you
your
mean
belief.
by
You don't need
ontological.
to. You need to learn some of
Well,
yourself. I've already taught you about
so
Coriolis and how the focal pendulum
I
works.
don't
Now
know.
you're fighting
You
me on
do?
this too.
so what
You're
he
wrong on
means
this as
by
well.
ontological is it's metaphysical and it goes outside the concepts
It
of
may be. Yeah,
natural
it could
law.
be. It could be. You know
Yeah,
what?
it's
That's
philosophical,
definitely
yeah.
that could be
Ontological,
a good point
philosophical,
there.
pretty close. Janet, can I explain? Can I define this for you? Listen, according to relativity, a
If you let me
mass.
speak
No, I'm
afterward,
teaching all
yes.
the Glovers, please stop. So
Let me
a
respond after, though. The
mass,
only way I
a
agree to
mass
listen to
is
you.
encompassed in space-time, in the fabric of space-time, okay? And this
Yep.
mass displaces the space-time because the mass is taking up the
Doesn't
space, right?
displace it.
So what it does is the mass bends and warps relative to that mass sitting within it. Now, what happens is if you move through this fabric that is bending and warping, it slows time down by stretching it out because of the bending and warping, and it basically compresses the matter that's in motion. It acts as resistance. The bending and warping acts as resistance to the moving mass, contracting the matter because you're going into the direction of the bending and warping by moving in the direction of
mass
motion.
actually expands.
Hey, Zanick, can I say something? Because this is, I think, where the problem with you are.
Mass goes up. Mass goes up.
You say you would not experience a change in contraction that Witsit thinks we would have. Now, by that, I don't know what you mean at all. So what he thinks.
Because you're not listening
so
to me. You didn't
I
listen to
don't
my
see
sentence.
I don't see that he's saying a change in contraction, although that he is saying everything physically contracts.
We can see this. We measure this for sure.
We
can
only
measure,
observe it under certain circumstances, but yeah.
Right, but the circumstances are the faster we go, the more that frame we see in it contract. And if that happens, if what he says is true, which is not, people inside that frame, if they're in that frame, would see everything contract based on who's observing
No,
it.
they wouldn't.
That's incorrect.
Because the contraction itself,
that's
you've
covered
already said
with
the contraction. Oh my
co-moving reference frame.
Let me finish.
Dude, Battlemod, all they
It's
have
impossible.
are straw man
you
fallacies.
can't. You already have your mind made up. You're not letting me talk.
Because you're straw manning me.
Stop. First off, Witsit didn't say you would experience within that reference frame. Second off, it's already covered by co-moving reference frames. We already covered it with everything within that reference frame.
You can't notice it because the entire frame contracts. You can't notice.
This is what Einstein himself. This is what Einstein himself said.
You can't notice it because the whole. He said
co-movers in a reference frame. Listen, you won't let me finish and you're getting angry, but I'm going to politely and quietly just keep talking over you until I finish what I'm saying. Einstein himself said everything in that coordinate system, in that moving reference frame, is going to contract. So nothing within that reference frame would even visually observe a contraction, and that's because everything's contracting. The tools of measure, the unit of measure, the device you're using, everything in that co-moving coordinate system is contracting. So how would one observe in that coordinate system any contraction?
They wouldn't, right? And there would be no shortening for
Exactly.
them. Yeah, exactly. Shortening means there was a length and then there was a shorter length. It got shorter to the other length. That doesn't happen. There's no shortening for you because everything is moving together. Okay? It's very simple.
You're just not getting it, Mike. So let me speak. I'll let you listen. I mean, I would listen anyway without being muted. But I'll explain to you really quietly and calmly. Yes, everything in that frame is contracting. The length is contracting. You're contracting. The space around you, all contracting in that frame. But that is with respect to another observer that is not co-moving, i.e. not moving with you. So the logical thing to say here is if I can then fly by you, Einstein says, let me finish. I always tell you what I'm going to say, then I back it up, and that's when you start talking over me. So just let me finish it, and you might understand what I'm saying.
Dude, move on. Shut up.
It's clear you don't understand what I'm saying. So what I'm saying is, yes, relative to something else, this is the contraction you see, and no one can see it in the moving reference frame because, like he says, everything contracts. But what if something else goes by you even faster? What if some little capsule goes by you at 80% of light speed, as I said to you in your private message? Then you would see that frame compress even more. But the people in the frame aren't seeing anything compress even more. But you see them compress even more. How is that possible? It's
because space-time bends and warps relative to the relationship between two observers.
No, it doesn't. Mass
oh my
goes
God,
to infinity
you're dumb. You don't know what you're talking about.
So you keep on saying that, and you are interrupting me to make more of a shit show than this really has to be. No,
just finish what you're saying with it.
Oh my God, mass goes to infinity. Mike,
calm down.
I asked politely for a couple sentences.
Dude,
and
calm down. I'm saying finish your fucking sentence, and you're getting pissed off, dude. I'm not gonna just mute you the next time.
Well, thank
you.
Calm
down, man.
I get upset when I get spoken over, especially when I got permission.
Everyone does.
No. And then Witsit finds that as soon as I make something he doesn't understand or is clear on, he feels compelled
to jump in. Get back to your point.
So my point is, if I let me make the point because it's pretty simple, and everyone in physics will agree with me, except for Witsit. Okay, so if something, you see this contraction and it's based on like the sun looking at the earth, and if you can't notice the length contraction on the earth because we are going at that velocity and we are seeing a contraction within this frame, this moving frame, and it's all relative and we're all basically getting compressed. Our ruler's being compressed, the apparatus is being compressed. We don't notice the contraction. Okay, I get that. But if that's true, then what if I whiz by in another object going twice as fast as 66,000 miles an hour? Instead of going near light speed, thousands of
I'm
times
with you now.
faster.
Let me
I
ask this
see the
question.
contraction even
Hold on,
greater. But
Gregory.
are people, let me finish. But are people on the earth or in that craft or whatever, are they seeing even more contraction just because someone whizzed by us? No. So the whole thing is
Right.
ludicrous. Witsit
So,
is high. It's not true.
well, so basically, what you're saying is how can both be true at one time?
Because he doesn't get it.
It's a law of
Well,
non-contradiction.
well, it's not actually contradictory to what's been stated. That we will observe a contraction that's going on outside of our reference frame, that's not co-moving with us. And you said faster than us, so it's not co-moving with us, it's moving at its own velocity. So yes, we'll observe that contract while we contract, and we don't observe us contracting. The two can work
Mike,
together.
you
What
hear
they don't
yourself?
understand is they're voicing
No,
their.
we
I did
understand,
hear
Mike.
I did hear myself. So
Okay.
you act
Well,
like you act like just because I'm contracting, I can't observe myself contracting, that my visual acuity or my observational acuity somehow contracted out of existence, and I couldn't watch something else contract as it moves at a greater speed than me, away from me, not relative to me. Well, relative to me, but not within the same speed frame as me. Come on, they've got varying velocities.
This is
I
what I'm
thought you got
saying.
it
Can
for
I
a
say
second.
something, please?
I
Can I
can give you
say
some
it's really
processing on
hard
that
to
real
listen to
quick.
Zanick
So,
just bastardize and
no,
straw man
I'm
Mike,
people.
trying.
Mike and I are
I'm
talking.
trying hard.
Let Mike and I go back and forth for a
Let's stop
second. Can I
saying
have a
my
one-on-one
name
with
so
Mike
many
for a
times.
second?
Stop saying what I say by straw manning it.
I'm
Yeah,
not
that's the
strawmanning
part I
you.
don't get. I don't
Well,
get what
here's some
how
clarity.
is Witsit understands everything that I'm saying right now, because I think you would agree that even though we're contracting, we'll still observe something moving faster than us to contract. Because
Yes.
why? Because that's the way it works.
Okay, but
Observations, light.
Mike, you forgot one
Listen,
thing.
light's bending,
You
time
forgot one
space is
thing.
warping.
No, but that's not how it works either. The thing going by you, whizzing
It
by you, even faster than we can imagine.
it
It
is.
looks at us and sees us contract even more than the sun looks at us and sees us contract. But we didn't see any different change in our contraction. That's the
That's
part I thought you
incorrect.
understood. Now hold on. Think about
It
this for a second.
contracts
We're looking out.
less. It contracts
Hold on.
less. It contracts
No,
less.
you seek the fast moving object sees a lot more contraction of us
No.
on the ground. Just like they look at us flying by at near light
Well,
speed and they think
yeah,
we're contracting.
it's
You're
like
saying like an
trees
object
and
goes by the Earth
listen,
Oh
faster than the
my
sun, it's going to see
God.
more contraction.
Please, just
listen.
let me
I'm with
finish
you
the
now.
fucking thought.
I'm with you now. It's like mile markers on the highway where you're doing 90
Yes.
mile an
Now,
hour.
it doesn't matter who's looking at
Are you
who. If I'm looking at the sun or I'm looking at this object. So there's 6 things we got to think about. The sun looking at us looking at the sun. Us looking at the object looking at us. 6 things. Let's keep it straight. All of them going different speeds. One, let's say it's inertial, which is, let's say, the sun. Then we got us going 66,000, and then something going near light speed. Everybody looking at everybody else, seeing something compressed at a different level. Which is correct? Are we seeing it when someone's looking at us from that light speed object? Are we now compressed more? No, but it sees that if it's correct. No, we are not compressed inside of our frame relative to us. In our frame, we don't see compression because we're not being compressed. That's what relativity says clearly.
No,
The sun
okay.
sees
Can
us
I please
compressed at a
respond?
smaller rate, then the object sees us compressed. And
Okay.
we see
So,
them compressed, looking
oh
at
my
them, by
God.
the way.
You keep
My
on
God
strong.
can't help you. My God can't help you right now. Because you're so wrapped up in your own bullshit, you can't see straight.
Okay, so you keep on strawmanning my position to say that there is some type of absolute frame or absolute motion and that you would observe the contraction in the
I didn't
same
say
reference
that.
frame when you just said that I
That's
claim that you
No, I
would able to
didn't.
actually
observe it. He just
that's
said
one
that.
of the
Mike
problems,
gets it, I
man.
think, but that's not what I said.
There's well, that is one of the problems with relativity, is there's no absolute frame for this.
Doesn't have to
That's
be.
true,
Remember,
but it
it's just
doesn't matter. Like,
relative.
dude, please, Zanick,
It does
please
matter because the
stop, Zanick.
sun
We just
and
heard
that
you
other
monologue
object.
3 times in a row, and you
But
said
Mike
my
got it. You
argument.
can't get it for some
You
reason.
Zanick,
bastardized my
stop
argument.
interrupting.
Shut up.
All right, sorry.
Yeah. Okay, so the point is that all objects in motion contract according to relativity. All of them, period. All motions can result in contraction. Now, as they approach closer and closer to relativistic speeds is when you're able to notice the contraction, and when it's not that close to relativistic speeds, it's almost negligible. It's basically negligible. But all objects in motion contract. That's what relativity says. Relativity also says that everything in the universe is in motion. There's no such thing as stationary unless you're just referencing it from inside the same reference frame. So the wagon moving on the street, well, if you're in the wagon, you can say it's not moving. Well, which is moving, the street or the wagon? It's interchangeable. That's what it says. That there's no such thing as stationary technically, and that everything is moving and all objects in motion contract. Well, now specifically with Michelson Morley, they were using that the Earth is orbiting, moving around the sun. So Earth's motion relative to sun means that, to explain Michelson Morley, that the apparatus contracted a certain amount, and that amount comes from the speed of the Earth relative to the sun. The velocity of Earth, 30 kilometers per second, relative to the sun, means that the apparatus contracted this much to make up for the missing time difference that would have been there measuring that relative motion of Earth and the sun. But since you're on the Earth and there's that contraction going on between the Earth and the sun, but you're just on the Earth, you're not going to notice anything. You're not going to notice that it contracted in the direction of motion around the sun because you're on the Earth going around the sun. So for you won't observe it. There's a distinct difference between the observation and the physical contraction that happens. To be fair, this is a very frequent misunderstanding, even at the time of Einstein, so much so he eventually had to come out and specifically address it. Okay? And the Globers keep on conflating the actual and apparent, where they say, oh, when you go outside, you observe it or it appears to shorten. Oh, yeah, but if I'm over here, it appears to be shorter. No, that would mean it's just apparent. It isn't apparent. According to Einstein, it's physical and it's actual. And this is the confusing part for the Globers. All of space-time
not
bends
confusing
and
at
warps.
all. I'm trying to explain
Listen
that
carefully,
to you.
dude. All space-time bends and warps relative to the relationship of two reference frames, meaning the bending and warping, i.e. the amount of contraction, changes when you have different reference frames, relationships, okay? That's what it says. That's what it actually says. There's a physical difference in space-time based on reference
You're
frames.
literally
May I say
taking it
this?
out of context, as you do often. But I won't go on that kind of ad hominem attack. I will let you know that you've just said it correctly. We would expect to have a certain amount of contraction. And in the frame, we wouldn't notice it because the frame would contract around us, like you're saying. If that's what you're saying it would contract equally. The space contracts, the measuring tool contracts. But that's not what Einstein says. Relative to the sun, we would expect to see a certain amount of contraction relative to the sun, not in the frame. Nothing contracts in the sun. In an actual contraction from the sun's perspective. And something whizzes by at near light speed, we see way more contraction, but yet we wouldn't feel anything different. Nothing. Now, if it's by your logic, because we get tracked so much that we don't notice it because everything's contracting. But which is it? How much does it contract? Based on something goes by us and in the sun? Which frame do we use to compare it to? It
Zanick, you're making a
You
category error.
and obliterated what Einstein's trying to say
sun,
because we don't see it because it doesn't happen in our frame. It only happens
Zanick, you're
in the
making a category error.
I'm not making a category error.
You
The
are. The
contraction only
critique is
happens
this.
as
How
viewed
about
from a
because we've heard you enough. We heard you.
non-co-moving
Listen.
reference
We heard you.
frame.
We
It
heard you.
doesn't
You're
follow any other
conflating the
One of you
actual
got to
event
give
with
up.
the
frame.
apparent.
Listen, one of you got to give up, or I'm going to mute you both.
Greg won't do
Like,
it. He's being a jerk.
no, he's dominating the room.
No, he won't.
I've been listening for the past several minutes.
Greg, let me
Listen,
ask you. If I whiz by,
hold on, Zanick. Even I muted to let Zanick and Witsit work this out. If Witsit still wants to continue, you should just let them two.
thank you.
But it isn't just them two. So
Okay,
to finally say this, because he keeps repeating his category error.
I'm not.
Listen, I know it's not just them two in the VC, but that doesn't address what I said.
May I say this?
Just in closure, just in summary here.
Well, I think okay. Let Greg make his point, and then Zanick, you can respond. I mean, you can have a couple-minute conversation. We've had it a lot. The only reason I want to, I just was trying to bring up things that people haven't heard to edify the room. It's the only value this is. Like they're just gonna keep screaming "nuh-uh" and then stating the same thing over and over. So,
right. So as he repeats it over and over again, what he's repeated over again is a category error where he conflates, like Austin just mentioned, and he just repeats his point where he conflates the actual objective event, the objective entity and the objective event with the perception thereof, and they keep incoherently interchanging them arbitrarily back and forth, back and forth, back and forth.
Yeah.
But that's what Dr. John Frame calls a dialectical tension. And that's the problem when you have an absurd, incoherent worldview. You cannot help but fall into that trap where you keep repeatedly jumping from one foot to the other. You jump from one premise to the other premise, which is contrary to the previous premise. You keep hopping back and forth every time one of the two is being attacked.
Yep.
Okay. Let me speak, Greg, and please don't interrupt if you could hold yourself back. No, I'm not making that fallacy. I'm not making that mistake as well. That's why I made it very clear that there were 3 objects of reference, 3 reference frames. All could be moving, but it doesn't have to be an absolute reference frame. So I'll make this very clear. It'll be one time. So here we go. We have the one frame. We don't know how fast it's moving. Sun. Earth. We know how fast it's allegedly moved, 66,000 miles an hour. And then we have another reference frame. Some guy going about near light speed. All 3 of those will have views of the other 2 and how fast and how much compression or how much contraction we see in those frames as observed by you in one of those frames. They'll all be different. So it's illogical to think that if we're on the Earth and we're measuring something from the sun and we see a contraction, that everything in that frame, the Earth, would contract evenly. The space, us, the measuring tools, the ruler, whatever we have, we don't notice any contraction because all contraction would be the same inside. But that's relative to the sun. And so it's contradictory and illogical to think that that happens because if something went by at near light speed, it'd look at the Earth and say, wow, that's really contracted because we're going really fast by it. But they don't feel that. It's only preferential. It's only preferential to the sun. No, everything should be relative to everything else, and it's not in his because this is Witsit's own logic. This is not how it's interpreted in physics. And every physicist in the world would agree with me. Thank you.
Well, you're just listen. It's not all relative to the sun contraction. The sun, it's relative to everything that's moving, and only when it's observational is it relative to another moving object.
Yeah,
well,
like
how
so
can
if the
everything
object
something else also
a
wanted to
reference
mention.
No, but you
the
said
object
it's
flies.
everything
Zanick,
is.
check it. If your object flies
I
by
know.
the Earth super fast, okay, what happens is that object that's going way faster past the Earth, it bends in warp space more relative to its
Why does that happen?
velocity. Dude, that is
Listen,
objectively what happens.
No, it's not.
listen. We can make the same argument, and we can stick to the highway. Like I use the mile markers because you got varying velocities of everything on the highway. Cars coming towards you, cars going past you, overpasses, road signs, trees in the distance. The size is going to affect how they observe, how quickly they go by you. Like a road sign goes by you quicker than an overpass does, and a car coming past you at 70 while you're going 70 the other way goes a lot quicker. But they're all true in the same frame at the same time.
Right, check this, right? So it says right here, it says,
but listen for a second. Wait, hold on a
please
second. I hate to
stop,
interrupt.
Zanick, let me please.
Just for a second, Mike, I got a funny thing to say real quick.
No. But if
isn't
you
it funny how
observe
things that are going by real fast are...
Oh, sucks. So, but if you observe length contraction, now what the Globers are saying is you can't observe length contraction on the Earth because no contraction is happening. That's what the Globers claim. You can't observe it because nothing's happening. I'm saying that relativity says contraction is happening, but you can't observe it because everything in that reference frame is contracting at the same rate. So you'll see no difference and you won't be able to observe it. They're saying you can't observe it because nothing happens. Okay, here, let me read it. The length, if you try to observe length contraction, you cannot because your view of it is compensated for by the finite speed of light. It literally says, if you try to observe length contraction, meaning length contraction that's happening, if you try to observe it, you can't observe it. They don't say because it doesn't happen. They say because your view of it is compensated for by the finite speed of light. And that the idea that objects contract in length in the direction of motion is a widely accepted consequence of Einstein's special relativity. But if you could observe such an object contracting in length, it wouldn't look shorter at all. Thanks for playing.
Yeah, when you're observing it right at a distance, and observation is done through light. and it's moving towards the speed of light, and that gives lag to the light that's being fed back to you as it makes ripples through time and space.
Yeah,
But
it very
it's
Right?
clearly states it,
contracting.
right? I mean, it clearly
But it's
says that if the
contracting relative
object
to you, and
contracts
now
in
he's saying that it's expanding. But my turn now. You're just making things up as you go, and it's not making a sense with it. I just hope you know that. You
He
think you're
didn't
saying
say
things that are making sense,
expanding.
they're not. Okay, listen. So we have some go by really fast. He said we're bending space time as we're going through it, as we speed of light. This mass is going to go to infinity. It's going to get bigger.
Does
That's
mass
what that's
warp
what that's what
space
that's what
time?
that's what Einstein. But
Does
no, it's
mass
getting smaller.
displace?
But it
Does
doesn't
mass
matter.
displace space? It
We
does, and
see
which causes
Mike.
time dilation. And now this causes drag and light.
Time
You
dilation for
can't.
who? Time dilation for who?
Dude,
For
they
the guy
think
in
they're
the object,
smart,
right?
and they just sound so stupid. Like,
Relative to you on the Earth, the time slows down. But on the ship that's going by at near light speed, your
Observationally,
time has not changed.
observationally, yes. In
Zanick, can we
Whose
actuality,
try this?
observation? On the
no.
ship? Then why do we
Zanick,
see it? Why do we see this happen? Because all this is measured in one way or another by by using relativities, distinct, defined spectrums by other reference frames, by contrasting reference frames. The only way you can see these effects. That's why we use it with satellites, GPS, for example.
I
Things
want to
are not
mention this.
compressing. Things are not
Eh,
contracting in that
Hey,
reference
you
frame
know it was funny
any
as shit when we
differently
tried to
by
get the
how something goes
muon
by you or
in
what
the
you view it
decay of
from. It doesn't
particles
matter.
earlier, and he blunked that shit. He didn't even want to cover it.
Yeah, can you guys give me
I
just
wanted to
one
He should
second?
mention
have. He
Zanick,
should
let's
this.
have
try
covered
an
it. And
experiment.
I
Please, and
actually
I'm gonna
probably
fall back
messaged
out of it
Mike.
because I think
I
people are
messaged
tired of
him to
hearing
tell
me
him
and
he's
you talk.
blowing
Oh
it.
my god, dude, you just can't help yourself, dude. I think people
Yeah,
are probably tired of hearing me say the same thing to you and it go back and forth. I'm gonna ask you,
probably.
Zanick, please. I'm gonna disengage if you don't do it. Okay. I'm gonna ask you very point blank questions that require like just a word, a yes or no, or a couple. I'm gonna ask you like 3 questions, and then we're gonna move on, and you can talk to someone else about it. Okay. So just try to see if you can be a big boy and just answer the questions directly. Okay. Here's the sentence again. Right.
Yeah,
So it says that the idea that objects contract in length is a widely accepted consequence of Einstein's special relativity. So here's the first question. The idea that objects contract in length. What is it? The object is doing what?
It's contracting in length.
Okay, thank you. Okay, so then it says, but if you could observe such an object, what object are we observing?
You would observe the moving object.
Okay, look. The idea that the object's contracting
You
length.
don't. You don't.
I
You're
asked
going to
you,
tie yourself
what
in
is
a
the
knot.
object doing? I
Yeah.
asked you, what is the object doing? You said contracting in length. I said, okay. So then it says, if you could observe such an object, what object was it we were just talking about? The object that's
When it's
doing what?
moving. When it's
That's doing
moving.
what? No,
Compressing.
it's
Contracting in length.
thank you. So it says, so if you could observe an object that's doing what?
Contracting in length.
And then it says, it wouldn't look shorter at all. So it's saying the object that is contracting in length wouldn't look shorter, correct?
If it says that, I want to see the rest of the article because that I don't know what he's referring to.
Okay, but you
Because
agree
it
that's what
does
the
look short.
statement
That's the whole
says?
idea what contraction is. It's reference frame dependent. You see an object look shorter as it moves by you at more relativistic speeds,
Okay, that's
or any
another
speed.
apparent
Actually,
argument. Do you agree that that's what the statement says? Yes or no?
who said it? And how
No.
is
No.
it?
Do you agree that's what the statement says?
I agree. You're reading it probably. I don't know what you're reading from. I have no idea
But
what you're reading.
okay, so the statement agrees with me, right?
No, but we see these things. We can actually measure these things.
I asked you to just answer the question. Does the statement agree with me? Yes or no?
Agree with you about what? No.
It
Why would I
says
agree with
that
you?
it says if an object is contracting in length and you try to observe that object that's contracting in length, it wouldn't look shorter. It literally says exactly what I'm saying, that the object's contracting in length, but if you tried to observe it contracting in length, it wouldn't look shorter at all.
Then you must be in the co-moving reference frame.
Okay, but in that co-moving reference frame, the object's still contracting in length, right?
Only with respect to another reference frame.
It
When it's not
says
co-moving.
right here, objects contract in length. But
Yes,
if you could
as
observe
referred
such an
from
object, it
from a
wouldn't look shorter.
non-co-moving reference
You guys
frame.
see the problem we have? Like, I couldn't make it any more clear right then. That's as
I
simple
see the
as like
problem. You're not
a
listening to me.
12-year-old could have understood it.
Witsit, it is common knowledge. Every physicist would agree with me that when you look at something having length contraction, this principle that is fundamental to theories of relativity, that it only happens when observed from a non-co-moving reference frame.
Yeah, it's that you can only observe it whenever you view it from a non-co-moving reference frame.
You just said that doesn't
that
happen. You
all
said you don't see
objects
it in
are. Dude, Jay's agreed with me, right? And what he says, he teaches at Ivy League school. I don't know how true that is, but
Yeah, he does.
right, and many other. I've actually talked to other physicists about it as well, right? So when I explain it like this, every physicist says I'm right. When I say, "Do you agree that relativity says all objects in motion contract?" But if you're in the same co-moving reference frame as the object contracting, you won't be able to observe it because
I know,
all
and
of
I
the
agree
space
with you as
around
well.
you is
I've always agreed with
contracting.
that.
They literally all agree, and then I say, and
I
then of
agree
course,
with you.
okay,
That's not the
okay.
point.
So then if you're in that reference frame,
How
even
much
though there
does
is
it
contraction, you won't be able to see it because of all of
in
the
the
space around
co-moving
you
reference frame?
contracts
I
with you,
agree.
and all motion is relative. So until the only way we can get the rate of contraction that is observable and detectable, then we have to have a reference frame that it will be relative to know
Right.
how much contracts based on motion,
Yes.
which is only relative.
Yes, but you're saying
Okay, thanks
everything
for
I
playing.
just
I've been right for
said.
3 weeks. I've been right for 2
No,
months.
you're
I've
not,
been right the
because
whole time.
no, it's not, because you don't see this fringe shift because of everything in the reference frame contracting. That's not an
Yes.
answer, because it would be different if you looked at it from an object that was going even faster than we are.
That's
And that was
a
my
red
point.
herring,
That was a
dude.
slam dunk, and it's still not, because you're not understanding what I'm saying.
Okay,
That that's
wait. Do you agree
relative.
that in
It's
Michelson-Morley,
relative
they
to
assumed
a
that the
non.
Earth was going
Let me
around the
I
sun?
listened to you. I played your
Yeah,
game. Now
fair
listen
enough.
to me for a
Just
second.
I don't want it to take
When
forever.
you are in a non-co-moving reference frame, you will see that contraction. That will be seen and detected. If you're
Okay.
in the co-moving reference frame, you will not. I
Okay.
agree.
Okay, so here's my question for you. Do you agree that in Michelson-Morley, they used the Earth's orbital speed to get their prediction? Yes or no?
Yes.
Okay. Do you agree that the orbital speed of the Earth is a motion that is relative to the sun?
Yes.
Okay. Now, do you agree that they used the Earth's orbital speed to get their prediction because they shot one of the light beams perpendicular to the orbital motion of the Earth?
Yes.
Okay. So they expected to see a fringe shift with that perpendicular light beam going perpendicular to the motion of the Earth, and they got the predicted value of 0.04 fringe shifts, and they did not get it. So what
Correct.
Einstein says is that in that motion, that relative reference frame of the Earth moving around the sun, as you try to detect the difference in time, you couldn't, because that apparatus is contracting relative to that reference frame that you're trying to detect the motion within, which is the orbit of the Earth relative to the sun.
Correct.
Oh, now you get it. So relativity
No, I
says
always got it.
the
But I'm
apparatus
telling you, not.
contracts in the direction of motion of orbit around the sun.
But you're not going to be able to detect it because you're in the rotating reference. You're in
That's
that
my
moving reference.
point. That's the whole point.
No, that's my point. Because why would you see any velocity? Because it could be relative to the sun when you're not. Doesn't matter if you're going. It's like, remember I told you about the mental experiment of being in a
Bro,
train
you guys have been
and throwing the
saying the
ball.
same
Hold on, let
thing.
me finish. Let me finish.
Do you guys want to
Throwing the
hear
ball
the
with
side
my
to
sixth?
side, window
conclusion.
to window, window to
You want to
window,
hear
or
the
down the aisleway.
sixthness?
Wouldn't be any different. There wouldn't be any difference because it's all relative. The
No.
motion's relative. That's why, in effect, in an easy layman's
So they
terms,
wouldn't have
why
been able to detect it.
no, if you throw the ball down the aisle of a train, 40 miles an hour, down the aisle or window to window, 40 mile an hour will still be 40 mile an hour. There'd be no fringe shift if you could have a fringe shift with these
Stay in the
baseballs.
same
You know what I'm
example.
saying? That's the
Oh, we're not
analogy.
saying the same thing,
May I
Wyatt.
If you
mention
don't
this
care,
finally?
Go explain what it actually means as it
you're
applies
moving
to the
around,
apparatus of
you're moving
Michelson-Morley.
around
They say
around the
no.
sun, you're not going to see any fringe shift because you're in that rotating object.
Okay, I've said that for 2 months now. I've said that
Oh,
you're not gonna I've said that
the
relativity
contraction
explains that we
dependent upon
don't see. Dude, please, I'm gonna stop talking to you after this. This is the last time I'm saying something because I've talked about this a million times, okay? I've been saying for months now that relativity says you do not see the fringe shift in Michelson-Morley because you would never be able to see it. You're not expected to see it because according to relativity, the apparatus contracts in the direction of motion around the sun. So if you're trying to detect that that difference in time based on the motion around the sun, you're not able to detect it because it's contracting in that very same direction. And in fact, it contracts the very exact amount it needs to make up for that difference in time. Therefore, they explain the negative result by saying you wouldn't ever see it because the apparatus is contracting.
You see the logic that's flawed there? Yes, it wouldn't happen if there was an ether, and it's not happening because what you just said, there's going to be a contraction that's not going to be able to be viewed by the co-moving observer. But that doesn't mean that there isn't a contraction. Contraction is viewed external to that frame. That's
Hey,
just saying
guys,
you can never be outside that
came
frame.
to
He doesn't understand that. He just
hold
lost.
on. You came to a consensus. Now we're going to open the floor for everybody else that's been waiting a half hour, maybe 2 to talk.
All right.
I just wanted to mention this is the concluding premise which Zanick has been trying to defend. There's something called analytic philosophy, where the philosopher is analyzing the suppositions being given. And the supposed concluding premise is denying an absolute reference frame and then asserts that everything is relative. When you suppose that everything is relative, that is an absolute statement about all entities within the whole universal state of affairs. So
Gregory?
when they make the supposition, they are simultaneously affirming an absolute characteristic about the entire universe while simultaneously denying an absolute characteristic of the universe. So that's an analytically false, self-contradictory concluding premise.
No, but we already, and Einstein says this, there are no absolute reference frames. So that's actually not saying what we're saying at all. Things being relative is based
you see, he's about to do it. He's about to do it.
Is relativistic speeds.
He said it pretty well that to say all things are relativist. Say it for me. Fuck it. I can't pronounce it.
Relativistically.
That's an absolute statement. All things in the universe are relative.
No, an absolute reference frame would be some reference like the God.
To say all things in the universe are relative to one another in relative motion is an absolute statement.
There are no absolutes, which is an absolute statement, and then everything is relative, which is an absolute statement. They're simultaneously denying and affirming absolutes. It's self-contradictory, analytically false.
That's not. No, that's not. That even though it is a statement, it's not absolute in the sense that
all things are.
Well, we know in physics that relativity is a concept that is understood by all, and that everything is relative to everything else. That's part of physics.
Which is a truism. So to say that everything is relative to everything else is simply to say that everything is related to everything else.
No, it's not.
You're denying absolutes when you say that.
Only in
and
terms
so
of motion.
when you insist on denying absolutes, he insists on talking through me. When they insist on denying absolutes and assert that everything is relative, then that necessarily implies that there's only local particulars relative to local particulars, but there is no absolute characteristic to anything, especially the macroscopic state of affairs of all entities involved. So that statement is self-contradictory, analytically false.
Yeah, but listen, relative motion is only observably true anyway. So the relative motion kind of implies that a thing can't be in motion unless it's in motion relative to another thing. But that's not true. A thing could have velocity minus every other thing in the universe. So it's only through observation that it becomes relative or observed.
Right. One can perceive the object is moving relative to the reference frame the entity is moving in. But in principle, whether you perceive it or not, an entity can be in motion whether you can perceive it or not. And even when there's nothing else to perceive as being stationary so as to detect the entity being in motion.
Yeah, so relative motion makes the assertion that if I can't observe it to move, it's not moving, which is fucking asinine.
Yeah, that clause, relative motion, quote unquote, is simply referring to one's perception of the entity moving. over
Yeah, but if
against, as
something's
opposed
not
to the
moving with
actual
respect to
event
you,
independent of the perception
Gregory.
of the event.
Yeah, Gregor, if something's moving with respect to you, then it will not look like it's moving because it's defined as the relative velocity or change in speed or position relative to you. And if it's not
Listen,
changing, then it's not moving
you
with
want to
respect to you. It's not that complicated.
No, just
Now, is it
because you
moving with
cannot
respect to something
perceive
else?
the
Hold
entity
on.
moving.
Is it moving
I'll
with
give
respect to
you
something? As
a
you talk right
relative
through me. As
observation.
you talk
No
right
matter
through me,
what I
brother. How
think
you want.
about Gregory, no matter what I think about Gregory, he's a very well-spoken person.
Yeah, but that doesn't
Thank you.
give any accolades to
I'm
his
not giving
confusion
accolades.
or
I'm
his
making a statement.
incorrect assessment.
It's not a debate. It's just a statement. Well-spoken
Yeah.
doesn't mean correct.
Right? You know you're well
You're
spoken
you're
when the
you're
people you're
fucking
insulting
straw
don't
manning.
understand the words you're using. Sorry.
No, no, not at all. You don't get it either. No, it actually happens from the other reference frame. It actually happens from the
That's
moving reference frame.
actually
As
that
you talked
that's
right through me. Great.
that's that's
No,
actually what's happening. Relative
no,
to
that's not
my
what I said.
opinion, relative to my opinion, that's actually what's happening.
Yeah, everyone agrees
So
but
at
you,
this rate,
perspective.
I mean, it's very obvious that Zenick is just being invincibly ignorant against any critique. You have
This is not. No, I'm not.
repeatedly conflated
I
perception with
listened very
actual
carefully to Witsit's
objective event.
explanation.
Just because
I
you don't
listened to your
perceive the event doesn't
philosophical
mean the event is not
analysis.
actually objectively occurring.
It is occurring. It is objectively occurring.
Yes, it is actually occurring. Just because you cannot perceive it does
No,
not
you can
mean, it
perceive
does
it.
not indicate that it is not actually occurring.
That's not true either. That's not true either. This is not a philosophical debate. This is physics. Yes, it's actually happening from the observed reference frame, not
He
the actual.
killed Schrodinger's cat. He
No,
killed.
no, nothing's happening. Einstein's
He
very
just
clear.
broke English
Einstein's very
syntax with
clear.
that sentence.
Einstein's very clear. Gregory, I'm
Yeah.
speaking. I'm speaking. I'm
Oh
speaking.
my lord!
You
Einstein's
say
You're
very clear that
killing
there's no
Schrodinger's
contraction
cat.
in that reference frame. Einstein's very, I'm going to keep on saying it until you stop talking. Einstein's very clear to say it's not happening in that reference frame.
this is so
Einstein's
stupid.
very clear to say that it is
Guys,
not happening.
guys. One of you got to give up. Come on. One of you got to let the other speak and then go back and forth and back and forth. You're giving me a fucking headache. Come on, man.
How about two other people start talking?
My answer is clear if you were not talking over me. In the reference frame that is moving, the co-moving reference frame, you will not observe any contraction, and Einstein's very clear about this. You only see the contraction from a non-co-moving reference frame, and it is actual from the non-co-moving reference
Well,
frame. Why is this so hard?
So
well,
with
I was
that
in
being
that
said,
reference frame. Oh, hold on.
Okay, which reference frame? Which reference frame? You need reference. You need other frames to be referenced to. That isn't the problem. It's your problem. Nothing ever contracts in your reference frame.
because
As you move, you never see
Appears.
you never have contraction.
in the world of relativity, everything is apparent. There is no absolute. That's the problem with this whole stupid ass
That's not the
theory.
Yeah,
problem. It's not
exactly.
apparent. It's not
yeah.
apparent. From another
So
reference frame,
it
it actually
actually
does
states
contract.
it is apparent because it actually states that if you're in the reference frame, it will contract, but it won't appear to.
Because you wouldn't be able to tell me what is the absolute truth because you don't know what the fuck you are compared to something else. So
It
nothing
doesn't
is
matter.
real.
Einstein's
That's
very
basically
clear.
what the fuck you're saying. Like
Riggs,
I
Riggs,
understand what you
Riggs,
guys are saying. If there's no
Riggs, but you're not
absolute,
listening.
then
It doesn't
there's
have to
no
be
basis
absolute.
of understanding.
There is no
Isn't it?
contraction in the
Listen,
moving reference. There is no
isn't
contraction.
this?
There is no
This is the
contraction.
very concept behind Schrodinger's cat in the box.
Well, look at the better one to look at is probably the
Yes.
ladder in the barn.
If you didn't see a dead cat in the box, if you didn't see a dead cat in the box, and it's not a dead cat in the box, it's just a box.
The better one, Mike, is the ladder in the barn. The ladder in the barn is the best one I've seen to really explain what's going on.
Well, they're all the same thing. And the truth is, and we all know it. The tree in the forest doesn't make a sound. It can all be the same thing. But the truth is, we do know that it makes a sound because we've experienced that. We know if we stick a cat in a box for too long, it's gonna fucking die. And we know if all things move at these speeds, then they have to contract. So it's not about whether or not you can observe it. It's about whether or not it actually happens. And I thought we were going to move on from this conversation to a different topic, guys.
As the last point, no, that's not it all.
That's because
Einstein was very clear.
In a relative universe, it's all about reference frames, and Riggs is right.
In addition, with the fact that this is the second and last critique, is that given the premises he's reiterated over and over again, is that he is trying to defend the concluding premise that, well, I don't observe it, and this is why I wouldn't be able to, this is why I couldn't observe it. If that is the premise that he wants to defend, then he's conceding that he cannot empirically detect the supposed phenomena that he supposes is occurring. So he's saying that he cannot demonstrate the empirical adequacy of his concluding premise. And then the premise, the theory that he's trying to defend, is self-contradictory on its face. It's analytically false. So it's both empirically inadequate and incoherent on its face.
Bunch of nonsense. I think it's my turn. Okay. You want to hear it? You want to hear it anyway? So I was going to give my closing statement. Closing statement is this. Shut up. Shut the hell up. Well, you haven't let me respond to you. You made an incorrect assessment, an incorrect interpretation, and you weren't listening. I said that very clearly, that you are not ever going to see something track in a moving reference frame. Einstein says this specifically. Now, if you read it differently, you're reading it wrong. You're taking it out of context. You see the actual contraction, Riggs, from a non-co-moving reference frame. You actually can measure it from a non-co-moving reference frame.
That's great. Which one is the real one?
Right. So, in other words, you cannot demonstrate the empirical adequacy of your
they're only real towards each other. What if there's another one outside of it that's the real one? How the fuck would you know?
If that was true, we couldn't have a GPS's work. We're counting on this to be true. These relativists.
Yeah. And what's worse is that these guys will say that they can't be totally sure about anything. So on one hand, they're saying, "Oh, well, we totally fucking know," and then on the other hand, they're saying, "Well, you can only be 99.9% sure." So
right,
in
which
reality,
is a concession, an agnostic kind of confession, right?
Yeah,
where they simultaneously have knowledge and cannot know.
Is essentially, well, as complex as we are, we're fucking stupid. We can't know shit.
They just talk at the same time. It sounds great.
Well, I thought I was trying to finish
up. This is high school physics. This is high school physics. I teach it. It's correct. Everyone will agree with me and not with me. Or with you, or with Riggs. Mike gets it. You guys don't get it.
It's a real shame how they got Zanick, because he's thoroughly ensnared in the sunken cost fallacy. I mean, imagine going to school and having a whole occupation for a decade or multiple decades, and then the fundamental presuppositions of the worldview that was taught to you is not just incoherent, but analytically false on its face.
That's why they're so useful, Gregory. What an idiot.
Imagine finding out you wasted your whole life on nonsense.
Imagine waking up and realizing that nobody heard you because 6 people were talking.
Hey, Mike, imagine people telling you that air-fuel ratios over 14.7 are going to burn up your motor. But then you tell them it's at a low power setting, then it gets actually more efficiently through the over the road gas mileage wise. But they don't understand.
Yeah, but you know what, Zanick? I wouldn't go to their server to let them know for the last 3 years.
And of course, it's openly admitted that at the highest levels, like the intricacies are still disputed within relativity. They just come here on Discord with like rudimentary understanding of, like he said, high school physics, and they just pretend like they know it all and everything's known, and we just don't get it. Blah blah blah.
That's another thing
You
too.
don't
Like,
get it,
they
Witsit.
love to
Just like you
laud
didn't get
their
the
exaltation of reason, but they have obviously forsaken Occam's razor. They have obviously utterly forsaken abductive reasoning.
And nah, Zanick, it's right in his name. Witsit does get it. Duh.
He doesn't get it, obviously. He didn't get the Foucault pendulum either. He started talking about his independent reference frame assertion through the gimbal.
Hey.
We went over that. And finally, he didn't realize there was something called consequential angular momentum.
Listen.
Everything we do with Witsit, he gets wrong.
I missed that road sign because I was speeding at that time. It went by me at 130 mile an hour, so I couldn't read it. It was contracted.
Yeah, right. No, it would. No, it would. It actually would. No.
Listen,
No,
all I want to know
self-attack.
is if I move fast enough, will my penis grow?
Nope.
What is the premise in the doctrine again? Is it
she'll
the faster the
think it's
motion, the longer the extension?
She'll think it's smaller. She'll think it's smaller.
No, her vagina will contract with it.
Oh, that's a good point. Great point.
Well, I mean, okay, if we're being honest about this whole contraction thing, like you could probably use it in court and get out of a ticket. Not even kidding.
Yeah, so if the sophist wants to be bothered,
well, Your Honor, when we calculate that, Your Honor, when we calculate the aberration of light, relativity, and length contraction, I actually was doing the proper speed.
And the
And that whole courtroom just erupted into a physical cacophony.
He was turning the laser at the car next to me, not me. It didn't hit me, hit the car next to me. So he was actually measuring that guy's speed, not mine, due to Coriolis.
Mm-hmm.
Is that how you won your races, Zanick? Space time?
It happened, bro. Send me back to Hull.
Now, you see, this is a metaphysical doctrine, and this just demonstrates they're just infected with this kind of bigotous vitriol against philosophy. Anytime you get close to quote unquote philosophy, metaphysics, they just spaz out, but they don't understand like the general relativity and special relativity theory is categorically a metaphysical doctrine. Why do I say that? It's because it's specifically trying to address the nature of time and space. These are basic historical questions in metaphysics, specifically ontology.
Sorry.
Like, it's a metaphysical doctrine. It's not just physical.
Those are the ontological questions, yes.
The second part of my statement was how it obviously reduces human experience to absurdity. So they make the supposition of the theory, and then we try to see how that comports with our regular experience, and it is not just contrary; it is vastly disparate.
But honestly, it's kind of a toss-up between this and coverage over 6 hours. So I don't know.
How do you know stars contract? I see light streamers.
How do you know you're stationary?
How do you know you're not?
That's what we empirically observe, and given the absurdity of the contrary.
All streets are two-way, so we see movement, but we lack the we lack the frame of reference to tell what is moving, but we observe the heavenly bodies to move through our sky, 15 degrees per hour. That's what we observe. It's only through metaphysics, philosophy, that they try to reason to you it appears that way, but it's because we're moving.
Incoherent, empirically inadequate, untenable metaphysical doctrines. So that's what we empirically observe, number one. Number two, the contrary is empirically inadequate and then also reduces human experience to absurdity.
So how does the celestial sphere rotate above a stationary plane?
Now, when you ask the question how, do you mean what is causing the event?
Yeah.
Okay, because many people, the reason I ask this is because many people ask that question in
how
the
does
sense
my
of
neighbor fuck
why.
his wife?
Well, I mean, well,
Right, the
there is a
veracity of
counter.
the answer, the veracity of the premise, we observe the celestial bodies moving and we empirically detect we're not moving, is not contingent upon answering the question what caused that event to occur.
Well, could it be possible that there's a bias that we're stationary?
What do you mean there's a bias that we're stationary?
Because it feels like we're not moving. Does that mean we're
It
not
is a
moving?
natural bias.
I mean, except the whole world's
Right.
bias.
Yeah, because right, when he asked the question using the word bias, I feel like he's using the word bias in the sense of a kind of unjustified preference or an unjustified evaluation of the situation at hand, which would not be a fair critique, because there's a reason why it is said be suspicious of those who deny the patently obvious, and these persons who raise these questions, they firstly begin the dialogue as though they're so empirical and so rigorous and tough minded and just want to get the facts and have the most simplest explanation. But then when we begin the dialogue, and then they start asking questions that demonstrate their skepticism of what is patently obvious and empirically detectable, and again, the contrary being empirically inadequate and being absurd, untenable in principle, and also not practical, then they've exposed themselves as not really being empiricistic as they firstly made themselves seem.
Yeah, that's word salad. So, how do you know you're not moving?
That's not a valid critique. It's not word salad.
There's
no indication.
How do you know you're not moving?
There's no indication of movement.
But there's not.
The only
All right, so
reason
once
we know
again, a very simple question that you asked, a very simple question you've asked, we empirically detect it. The contrary is empirically inadequate. We don't empirically detect the contrary. And the contrary is absurd. It is untenable upon scrutiny.
Well, it's not because when the reason. Hang on, just the reason this question. Well, a bottle of liquid and gas has been dropped on Earth. There's no fluctuation in the container when dropped. That proves there's no acceleration down.
Okay, there's
What
no
did you
downward
just say?
acceleration. That's not what the globe even says, so why would you be getting us to substantiate there being no rotating globe? Because the globe doesn't say there's no downward acceleration.
We're not talking about rotation or free fall. We're talking about laterally when you go
There is
from
acceleration
0.
in a rotating reference frame, constant acceleration. So I don't know what you're talking about here.
Well, when you
Let's try this
fluctuate,
again. What are you saying to us?
if you're in a stationary,
It's not what I was talking about, Michael, but anyway.
So you guys are triggered and defensive.
No,
Sky, what are you saying to
you're
us,
free
Sky?
to finish.
I'm
Let him
saying
finish.
that a bottle of liquid, water, and air, gas, has been dropped in a container. A bottle.
The
And
bottle
when
is
you drop it,
dropping in the container.
Sorry, this is hilarious.
Just
when
let
you
him.
drop,
Just
when you
let him
drop,
finish, guys, please.
when you drop the bottle, there's no
Okay.
displacement in the gas or the liquid in the container.
Displacement, like a
Is that a
density
real
power,
phenomenon?
where the volume
Yeah,
of the water or the object that's placed in the container displaces all the water in the container. Are you with him? So I don't know how it applies,
when
but
you
I
do it
understand what
laterally,
displacement means.
right. When you're stationary and you move, you accelerate or decelerate, there'll be displacement in the container with the liquid and the gas. When you do it
But when you're
vertically,
stationary and then you move, is that what you mean?
yeah,
Okay.
stationary to acceleration, the thing that will let you know you're accelerating is the displacement in the gas and the liquid.
Okay, so once again, that right there is your detection of the event, of the motion, as opposed to the motion actually happening, whether you detect it or not. Okay.
Yeah, that's the first thing he said. The lack of displacement proves we're not moving or accelerating.
Okay.
Yeah, that's what I was trying to get at.
Yeah, like
I mean,
He was
like
you guys,
like the volcanoes. The whole pillar of smoke that comes out of a volcano. You don't see it, you know, being wisped around. As it's
Right.
just
Well,
only traveling upward.
it's no different than a glass of water on the floor and some big guy gets up and starts walking by it. You'll see that in the water in the glass.